Welcome back to the office. We want to continue taking a look at groups, and in this case, we're going to look at elementary properties of groups. We have 4 properties that we would like to take a look at, so we'll do actually 4 videos, just that way we don't get overwhelmed with what we're looking at. So one at a time here. We have our first one is from the textbook, Theorem 4.15. If G is a group with binary operation star, excellent, that's what we want, then the left and right cancellation laws hold in G. That is, A star B being equal to A star C does in fact imply that B is equal to C. Similarly, B star A being equal to C star A implies again that B is equal to C. Right, so we want to be able to cancel these things and cancel these things to get B is equal to C and B is equal to C in both cases. Now, the tricky thing is that it only applies left and right. If we were to have A star B is equal to, let's see here, C star A, this does not necessarily imply that B is equal to C. The problem here is if I multiply both sides by the inverse, A prime star A star B is equal to A star, A prime star C star A. Let's see here. Yeah, do that. Sure. Right, we have a cancellation here or a simplification, so we get B is equal to A prime star C star A. So think about it, under what circumstances do we get that these cancel out, right? Think about that. I want you to have that answer in mind, because in general, these two things don't cancel. Okay, why? You should know the answer to that. All right, so however, I can multiply by the inverse on the left without any issues and multiply on the right by the inverse without any issues. I get cancellations and life is good. So what I'd like to do is I'd like to write up the proof for this. Again, based on this and what I've just said, we know what it should look like, but let's look at the formalities. Let's remind ourselves of what it looks like to write a proof, since I think there might be some concerns there. So I'm going to let G be a group with binary operation star. Excellent. And we want to let A, B, C belong to G. Cool. Furthermore, we're going to assume that A star B is equal to A star C. And I think what we'll do is we'll prove it for the left cancellation law, and then I'll point out that the proof for the right cancellation law is the same. Okay. So assume that A star B is equal to A star C. By axiom 3, right, we need to satisfy the 3 axioms to be a group. There exists A prime in G such that A prime star A is equal to A, well, actually, that's the only thing that I need. I don't need A star A prime, but this is equal to the identity E, whatever the identity happens to be. So here, E in G is the identity. Excellent. Then we have, so we can take A star B being equal to A star C, right? That's what we start off with. And I'm going to multiply on the left by A prime. When I do that, I can recognize that G is associative, so I can combine these two things. A prime star A star B is equal to A prime star A star C. Life is good. We have that A and A prime are inverses, so we get E star B is equal to E star C. Now, this might seem like it's just a lot of details that don't need to be there, but I'm really trying to make sure that we understand each individual step and the importance of those axioms, right? So this first step requires the first axiom be true. This next step requires that second axiom be true. I'm sorry, the third axiom be true, and the second, I guess, because we need the identity. So here within the second identity, I know that E star B is equal to B and E star C is equal to C. So I get that B is equal to C. Thus, the left cancellation holds. Thus, left cancellation holds. That's cancellation law. That's what they call it. Left cancellation law holds. Fantastic. Once I know that the left cancellation law holds, similarly, the right cancellation law holds. Okay, it's the same proof. You just multiply on the right instead of on the left. Uh, and that's what we wanted to show. We wanted to show that the left and right cancellation laws hold. End of proof. Boom, we're done. Right? Nothing too crazy, nothing super complicated. Just making sure that we know what things that we need from the definition of group and how they get used. And that's it. All right, so we're going to take a look at another property in our next video. I'll see you back here in the office in just a moment.